Hello, hello. Today we're doing LeetCode problem 1768, which is merge strings alternately. Okie dokie. You are given two strings, word 1, word 2. Merge the strings by adding letters in alternating order, starting with word 1. If a string is longer than the other, append the additional letters onto the end of the merged string, and then return that string. Super easy. First example, word 1 ABC, word 2 PQR. Basically the output is merging of those two words, alternating letters, so A, then P, then back to the B, then Q, then C, then R. Second example, word 2 is longer, so we're going to do A, P, B, Q, and then put RS on the end. Third example is the same thing, only word 1 is longer. So again, A, P, B, Q, and then the C, D at the end. So this is a very simple problem. We're going to start with an empty string, and we're going to traverse both strings, picking each character alternately from both strings and appending it to the result string. And then we just do that till we run out of letters in the string. And we're going to return that string. So let's get coding. So we need a string builder. We're going to call that result, and we're going to instantiate it. And for this, we're going to use a while loop, so we need a starting point. We're going to call that I. I'm going to assign that to 0. All right, so now it's just a big while loop. So while I is less than word 1 length, or I is less than word 2 length. So we're going to do some stuff. Well, we have to start with word 1. So if I is less than word 1 length, I need to stop drinking. What is with my typing? Or, nope, not or. All right, so then result, we're just going to append word 1. And we're going to use the charet function. So to append the word at that position. And then we have to do the same thing with word 2. Result, oh my God, append word 2 char at I. I literally can't type anything right. All right, so after that we need to increase I so we don't run into an infinite loop. And then at the end here we just need to return it. Return the result, but we need to toString it, or convert it back to a string. All right, let's see where I messed up. Holy cow, I didn't mess up. All right, so that's accepted. It ran through the 3 cases that were in the example. We'll submit it. La-di-da, looking good. Time complexity O of n. N is basically the length of the longest string. And space complexity, same thing. We just need space for the longest string. And that's it. So thanks for watching, and we'll see you next time.